Hi, good morning. We are going to look at solving rational equations, and I'll be doing part 1 and part 2, so this will be a part 1. So we are given x plus 4 divided by x equals to 3 over 7. So in this question, you realize that we have one fraction on the left and one fraction on the right. So if you have a situation like that, the best way to approach this is to use what we call cross multiplication. Right, so you're going to multiply the diagonals. So in this case, you're multiplying x times 3. Then we also multiply 7 times x plus 4. So it's going to look something like that. So 7 times x plus 4. So you want to put the monomial on the outside and the binomial in the parentheses, just to remember to distribute. You bring down the equal sign, then you do x times 3, which is 3x, right? So the reason for doing that is to get rid of the fractions. So once I do my cross multiplication, the fractions are no more, okay? So then I distribute, so I have 7x plus 28 equals to 3x. Now I'm going to get all the variables to one side. So I'm going to subtract 3x on the right and subtract 3x on the left, right? So I end up with 7 minus 3x becoming 4x. Then I move the constant to the right. So the plus 28 gets moved to the right to becomes negative 28. Negative 28. So now I can divide both sides by 4, right? So that I get x equals to negative 7. So now you want to make sure that the answer you got is right. So plug back the x value, which is negative 7, into the original equation to see if it will satisfy the equation. So if I plug in negative 7 here for x, negative 7 here, I'm going to get negative 7 plus 4, which is negative 3, divided by negative 7. And negative 3 divided by negative 7 is equals to positive 3 over 7. So this answer is good. Okay. Let's quickly do another example. So in example 2, we have the same situation. We have one fraction on the left and one fraction on the right. So we are going to apply the cross multiplication strategy, okay, where we are multiplying the diagonals. So I'm doing x times x minus 4. So it's going to look like this. Again, the single digit stays on the outside. So x times x minus 4. Bring down the equal sign, then I cross multiply the other diagonal, okay, so cross multiply that, so we have 4 times x minus 3. So this is what I have. Now if I distribute, I'm going to get x squared minus 4x equals 4x minus 12. Now this is a quadratic, right, equation. So we started with a rational equation. Now it looks like quadratic equation. So I'm going to move everything to the left hand side to make the right hand side 0 to get a clean quadratic equation to see if I can solve that. So I have x squared. This 4x on the right hand side move to the left becomes a negative 4x. So minus 4x minus 4 becomes minus 8x. The negative 12 on the right hand side move to the left, it becomes a positive. So now everything is gone, so I have a 0. So this looks like a clean quadratic, and we learn how to solve quadratics in several ways. So I'm going to use the factoring method because I can see that this can be factored. So I'm looking for two numbers that will multiply to 12 and combines to negative 8. And those two numbers are negative 6 and negative 2. So my factors would be x minus 6, x minus 2. So these factors, x minus 6, x minus 2, when I multiply them, I should be getting x squared minus 8x plus 12, all right? So from here, if two factors multiply to 0, it means either one of them equal to 0 or both of them equal to 0, what we call the product rule. So I will say x minus 6 equal to 0, or x minus 2 equal to 0. And if I solve for each case, I get x equals to 6 and x equals to 2. Again, you want to make sure that these answers are correct, all right? So plug them back into the original. So for example, if I plug the 6 into the original equation, I'm going to get 6 minus 4, which is 2, and 2 divided by 4 is 1/2. If I plug the same 6 here, 6 minus 3 is 3 divided by 6, so 3 divided by 6 is 1/2. So this answer is good. Likewise, if I plug in 2, it will check out. The left hand side will be equal to the right hand side, so that answer is also good. So this is how you solve rational equations if you have one fraction on both sides of the equation. Just apply the cross multiplication technique. I'll see you in the next video. Bye.